Right, girls, so 2014 now, part A. This was very long for part A question, but we're going to have a look at it. What you had to do was quite straightforward. It was just very long-winded. So it told you about 3 ships. They're observed from a Coast Guard station at half-hour intervals at 2, 2:30 and 3 o'clock. With distances measured in kilometres and speeds in kilometres per hour, they have the following displacement and velocities. So x's displacement from a certain point, y's and z's, and the velocities then are given in the third row. You had to prove that if x and z continue with their uniform velocities, they will collide. Okay, so will x and z collide? You've got to prove that. And remember, if things are going to collide, then the slope of the relative velocity line must be equal to the slope of the relative displacement line, the slope of the rxz. Right, the thing that you had to remember here was that you had to have a time common to both of them to begin. So the time had to be common for starting position. So because z started, we'll say z's sighting was until 3 o'clock, we would have to see where x was at 3 o'clock before we could compare and compare the slopes and see what was happening. So the first thing to do, you had to find where x was at 1500 hours. So this is its position, 2i plus 7j. Now it's going to travel on for an hour, travelling at 4i plus 5j. So I'll find its displacement. I'm going to use speed is equal to distance over time. And in these particular cases, it's displacement. So it's the positions of one relative to the other rather than just distances in kilometres or whatever. So speed multiplied by time would be the displacement. The displacement and the relative displacement I'm calling r, so the r's. Right then, so let's find the position of x at 3 o'clock. So I'm going to multiply its velocity, which is 4i plus 5j, by 1 hour, because it's going to take it to 3 o'clock, and see where it is at that stage. Okay, so that's going to just be 4i plus 5j. And now I'm going to add on its displacement, where it was at 2i plus 7j. And that will tell me where its new displacement is. So speed multiplied by time. So it's speed multiplied by time plus, I'm adding on to where it was at 2 o'clock to find out where it will be at 3 o'clock. And when I do that, I get 6i plus 12j. Okay, so that is x's position at 3 o'clock. And now I can do a vxz and an rxz. Okay, so vxz is vx, of course, minus vz, which the velocity of x is 4i plus 5j, and minus the velocity of z minus 2i minus 6j, and that, of course, will give me 2i minus j. Okay, now let's get the rxz. So r's position, remember, is now at 6i plus 12j, or x's position, so it's going to be rx minus rz. Rx's position is 6i plus 12j, minus z's position, which is 12i minus 12i, of course that will become minus 9j. And when I work that out, I'll get minus 6i plus 3j. Okay. So let's get the slope of these and compare. So the slope of the vxz will be the j's over the i's minus 1 over 2, and the slope of this one will be the j over the i's, which is 3 over minus 6. So in both cases it's minus a half. So therefore they collide. So collision occurs. Now, so that was the first part. Find the time to the collision. The time to the collision will be relative displacement over relative speed. Relative displacement over relative speed. Now, the relative displacement. the relative displacement, of course, we know is this one. So it's minus 6i plus 3j divided by the relative speed, and the relative speed is 2i minus j. So I'm going to get the modulus of each of those, and then I'm going to divide them in. So that will give me 36 plus 9, which is root 45. And this one will be 4 plus 1, which will be 5. So this will be root 9, which means that in 3 hours there will be a collision. So the time of the collision, that means if they set off at 1500, if Z sets off at 1500 and 3 hours later it collides with Z, with X, that means the time of the collision will be at 1800 hours. Okay, so that's the first bit. So first of all you proved they collided, and then you found the time of collision. Now, the next part was at the instant of the collision, ship Y changes course. And this is at 1800 hours. So it changes course at 1800 hours and goes directly to the scene of the collision to help. You have to find the time at which it will arrive at that scene. So you need to find out where the collision happens. So where does the collision happen, first of all? Okay, so we'll say Z's position was at 12i plus 9j. So the R of Z was 12i plus 9j. Now, where was it 3 hours later? So it's going to, what I'm going to do is find out what its displacement is 3 hours later. And to do that, I'm going to multiply its velocity, which is 2i plus 6j, by 3 to see where its displacement is 3 hours later. So when I do that, I get 12i plus 9j plus this is 6i plus 18j. And of course, that is 18i plus 27j. So that's the position of the collision. That's the position of the collision. So what I did here was I multiplied velocity by time, and that gave me the displacement that I added onto the original displacement. Okay, so now I know where the collision happens. Now, Y, remember, Y was here at 6i plus 9j. I'm going to have to see where is it at 6 o'clock when this collision happens. So, for Y is at position. Its position was 6i plus 9j. Now, I'm going to add on where it is now at this stage. So I'm going to add on the velocity by time, which will be its velocity, which is 3i plus 4j, multiplied by, now, that's where it was at 2:30. I have to see where it is at 6 o'clock. So I'm going to multiply that by 3.5 hours. And that will tell me what its displacement is at 3 o'clock. So I've got 6i plus 9j. I'm going to add on, when I add this on here, this will give me 10.5i plus, that's going to give me 23, that's going to be 14j. And when I add this together, this will give me 16.5i plus 23j. So this is Y's displacement, or its position, at 1800 hours. Okay, so to find out how long it takes Y to get to the collision, so the time is going to be the relative displacement over relative speed, and it's the speed of Y this time, just Y's speed. The relative displacement will be the R of Y relative to the position of collision. So I'll call the position of collision P. So I want the RYP over the speed of Y. And the speed of Y is the square root of 3 squared plus 4 squared, which of course will be 5. So I want the RYP over 5. Now to get the RYP, it's RY minus RP. So RY is 16.5I plus 23J minus the position of the collision, which is 18I minus 27J. And when I work that out, that gives me minus 1.5I minus 4J. So this is the relative displacement, this fella here. So the time will be the relative displacement over the relative speed. So relative displacement minus 1.5I minus 4J. I'm going to get the modulus of that over the speed, which is 5. So when I get 1.5 squared plus 4 squared, square root of that gives me 4.27 over 5. Now, this is going to give me 4.27 divided by 5 is 0.854. And of course, that's hours. So if I multiply that by 60, that will tell me that becomes 51 minutes. So find the time. So the time of collision, of course, will be 1851, because this all started from 6 o'clock. Or sorry, not the time to collision, the time for of Y reaching the collision position will be 1851.